It's 1 a.m., I can't sleep, and I ask myself something weird. How did people know the Earth was round before satellites? Let's go back in time. Ancient Greece. There was a guy named Eratosthenes. Eratosthenes, a Greek scholar and the chief librarian of the Great Library of Alexandria, was a man of insatiable curiosity and intellect. One day he came across a fascinating piece of information that would change the way we understand our world. He read that in the city of Syene, located to the south of Alexandria, the sun was directly overhead at noon during the summer solstice. This meant that objects, such as a stick or a column, would cast no shadow at all. Intrigued by this phenomenon, Eratosthenes decided to investigate further. He observed that in Alexandria, at the same time on the summer solstice, the sun was not directly overhead. Instead, it cast a shadow. This discrepancy puzzled him. How could the sun be directly overhead in one city and not in another, especially when both cities were relatively close to each other? Eratosthenes hypothesized that the Earth must be curved, and he set out to prove it. To test his hypothesis, Eratosthenes conducted a simple yet ingenious experiment. He placed a stick, known as a gnomon, vertically in the ground in Alexandria and measured the length of its shadow at noon on the summer solstice. He then compared this measurement to the information he had about Syene, where no shadow was cast at the same time. By calculating the angle of the shadow in Alexandria, he could determine the curvature of the Earth. Eratosthenes knew that the distance between Alexandria and Syene was approximately 800 kilometers. Using the angle of the shadow, which was about 7.2 degrees, he calculated the circumference of the Earth. He reasoned that if 7.2 degrees corresponded to 800 kilometers, then 360 degrees, the full circle, would be about 40,000 kilometers. Remarkably, his calculation was astonishingly close to the actual circumference of the Earth, which is about 40,075 kilometers. This discovery was groundbreaking. It provided one of the earliest pieces of evidence that the Earth is a sphere and not flat, as many people believed at the time. Eratosthenes' method was not only innovative but also demonstrated the power of observation and reasoning in scientific inquiry. His work laid the foundation for future astronomers and geographers, and his legacy continues to inspire scientists to this day. Eratosthenes' experiment is a testament to the ingenuity and curiosity of ancient scholars. It shows how a simple observation, combined with critical thinking and mathematical reasoning, can lead to profound discoveries about our world. His work reminds us of the importance of questioning the status quo and seeking evidence to support our ideas. In addition to his work on the Earth's circumference, Eratosthenes made significant contributions to various fields, including geography, astronomy, and mathematics. He created one of the earliest maps of the known world, incorporating the knowledge he gained from his travels and studies. He also developed a system of latitude and longitude, which became the basis for modern cartography. Eratosthenes was also known for his work in mathematics. He invented the sieve of Eratosthenes, an algorithm for finding prime numbers that is still used today. His contributions to the field of mathematics were highly regarded, and he was often referred to as the father of geography due to his extensive work in the field. Despite the limitations of the tools and knowledge available to him, Eratosthenes' achievements were remarkable. His ability to think critically and creatively allowed him to make discoveries that were far ahead of his time. His work serves as a reminder of the importance of curiosity, observation, and reasoning in the pursuit of knowledge. Eratosthenes' discovery of the Earth's circumference is a shining example of how ancient scholars used the resources available to them to explore and understand the world around them. His legacy continues to inspire scientists, mathematicians, and geographers, reminding us of the enduring power of human curiosity and ingenuity. As we reflect on Eratosthenes' contributions, we are reminded of the importance of preserving and sharing knowledge. The Great Library of Alexandria, where Eratosthenes served as chief librarian, was a center of learning and scholarship in the ancient world. It housed countless scrolls and texts, representing the collective knowledge of various cultures and civilizations. The library was a testament to the value of knowledge and the pursuit of understanding. Eratosthenes' work at the library allowed him to access a wealth of information which he used to make his groundbreaking discoveries. His ability to synthesize information from different sources and apply it to his own observations was a key factor in his success. This interdisciplinary approach is still relevant today, as modern scientists and researchers continue to draw on knowledge from various fields to make new discoveries. In conclusion, Eratosthenes' discovery of the Earth's circumference was a monumental achievement that changed the course of scientific history. His innovative approach to problem-solving and his dedication to understanding the natural world serve as an inspiration to us all. As we continue to explore and learn about our world, we can look to Eratosthenes as a model of curiosity, creativity, and critical thinking. His legacy reminds us that the pursuit of knowledge is a timeless endeavor, one that continues to drive human progress and innovation. So he measured the angle. He did the math. But this wasn't just any ordinary measurement or calculation. This was a groundbreaking moment in the history of science and mathematics. The man behind this incredible feat was Eratosthenes, a Greek scholar who lived in the 3rd century BCE. Eratosthenes was not only a mathematician but also a geographer, poet, astronomer, and music theorist. His diverse interests and talents made him one of the most brilliant minds of his time. Eratosthenes was born in Cyrene, which is modern-day Libya, around 276 BCE. He was educated in Athens, where he studied under some of the greatest minds of the era. His thirst for knowledge and his ability to think critically and analytically set him apart from his peers. Eventually, he was appointed as the chief librarian of the Library of Alexandria, one of the most significant centers of learning in the ancient world. It was during his time at the Library of Alexandria that Eratosthenes embarked on his quest to measure the size of the earth. The story goes that he heard about a well in the city of Syene, now Aswan, Egypt, where, on the summer solstice, the sun was directly overhead at noon. This meant that the sun's rays would shine straight down into the well, casting no shadow. Eratosthenes realized that this phenomenon could be used to calculate the Earth's circumference. He knew that in Alexandria, which was north of Syene, the sun was not directly overhead at noon on the summer solstice. Instead, it cast a shadow. By measuring the angle of the shadow, Eratosthenes could determine the angle of the sun's rays relative to the vertical. He used a simple instrument called a gnomon, which is essentially a stick placed vertically in the ground, to measure the shadow's angle. This angle turned out to be about 7.2 degrees, or 1/50th of a full circle, and he calculated the size of the Earth. But how did he do it? Eratosthenes knew that the distance between Alexandria and Syene was approximately 800 kilometers. Since the angle he measured was 1/50th of a full circle, he reasoned that the total circumference of the Earth must be 50 times the distance between these two cities. By multiplying 800 kilometers by 50, he arrived at a figure of 40,000 kilometers for the Earth's circumference. This was remarkably close to the actual value of about 40,075 kilometers. Eratosthenes' method was elegant in its simplicity and brilliant in its execution. He used basic geometry and a keen understanding of the natural world to achieve something that had never been done before. His calculation was a testament to the power of observation, critical thinking, and mathematical reasoning. It demonstrated that even with limited tools and technology, it was possible to unlock the secrets of the universe. Over 2,000 years ago, Eratosthenes' achievement was not just a milestone in the history of science, it was a symbol of human curiosity and ingenuity. It showed that with determination and intellect, we could overcome the limitations of our time and expand our understanding of the world. His work laid the foundation for future generations of scientists and explorers who would continue to push the boundaries of knowledge. Eratosthenes' legacy extends beyond his calculation of the Earth's circumference. He made significant contributions to various fields, including geography, where he created one of the earliest maps of the known world. He also developed a system of latitude and longitude that is still in use today. In mathematics, he invented the sieve of Eratosthenes, an algorithm for finding prime numbers that is still taught in schools, with just a stick and his brain. Eratosthenes' story is a reminder of the incredible potential of the human mind. It encourages us to look beyond the obvious, to question the world around us, and to seek answers through observation and reasoning. His work continues to inspire scientists, mathematicians, and thinkers to this day, proving that the pursuit of knowledge is a timeless endeavor. In conclusion, Eratosthenes' calculation of the Earth's size was a monumental achievement that showcased the power of human intellect and curiosity. It was a pioneering effort that paved the way for future discoveries and advancements. With nothing more than a stick, his brain, and a deep sense of wonder, Eratosthenes unlocked one of the greatest mysteries of his time, leaving a lasting legacy that continues to influence and inspire us over 2 millennia later. Then came the Renaissance. This was a period of extraordinary cultural, artistic, and scientific rebirth that swept across Europe from the 14th to the 17th century. It marked the transition from the Middle Ages to modernity, characterized by a renewed interest in the classical art, literature, and learning of ancient Greece and Rome. During this time, the world saw the emergence of remarkable figures who would leave an indelible mark on history. One such figure was Nicholas Copernicus, a Polish mathematician and astronomer. Copernicus stepped in with a revolutionary idea that would forever change our understanding of the cosmos. He proposed the heliocentric model of the universe, which posited that the Earth and other planets revolve around the Sun. This was a radical departure from the long-held geocentric model, which placed the Earth at the center of the universe. Copernicus's theory was met with skepticism and even ridicule. Many people laughed at the notion that the Earth was not the center of the universe. The prevailing belief, supported by the powerful Catholic Church, was that the Earth was stationary and that all celestial bodies orbited around it. This geocentric view was deeply ingrained in the minds of scholars and the general populace alike. However, Copernicus was undeterred. He meticulously gathered observational data and mathematical evidence to support his heliocentric theory. In 1543, he published his seminal work, De Revolutionibus Orbium Coelestium, on the revolutions of the celestial spheres, which laid out his arguments in detail. Despite the initial resistance, his ideas gradually gained traction among other astronomers and thinkers. The Renaissance was not just about scientific advancements, it was also a time of unparalleled artistic achievement. Artists like Leonardo da Vinci, Michelangelo, and Raphael created masterpieces that continue to inspire awe to this day. Leonardo's Mona Lisa and The Last Supper, Michelangelo's Sistine Chapel ceiling, and Raphael's School of Athens are just a few examples of the incredible artistic output of this period. In addition to art and science, the Renaissance was a time of great literary and philosophical exploration. Writers like Dante Alighieri, Petrarch, and Giovanni Boccaccio laid the foundations for modern literature with their works. Dante's Divine Comedy, Petrarch's sonnets, and Boccaccio's Decameron are still studied and revered for their profound insights into the human condition. The Renaissance also saw the rise of humanism, a philosophical movement that emphasized the value and agency of human beings. Humanists believed in the potential for individual achievement and the importance of education in realizing that potential. This shift in thinking had a profound impact on the development of Western thought and culture. The period was also marked by significant advancements in technology and exploration. The invention of the printing press by Johannes Gutenberg in the mid-15th century revolutionized the dissemination of knowledge. Books became more accessible, and literacy rates began to rise. This technological innovation played a crucial role in the spread of Renaissance ideas across Europe. Explorers like Christopher Columbus, Vasco da Gama, and Ferdinand Magellan embarked on voyages that expanded the known world and opened up new trade routes. These explorations had far-reaching consequences, leading to the exchange of goods, ideas, and cultures between Europe and other parts of the world. In conclusion, the Renaissance was a period of profound transformation that reshaped the cultural, artistic, and scientific landscape of Europe. It was a time when bold thinkers like Copernicus challenged established beliefs and paved the way for future discoveries. Despite the initial skepticism and resistance, the ideas and achievements of the Renaissance continue to influence and inspire us today. The laughter that once greeted Copernicus's revolutionary theory has long since faded, replaced by a deep appreciation for the courage and vision of those who dared to see the world differently. The stars, the planets, they moved in ways that only made sense on a round Earth. Then came the explorers. They sailed west and kept sailing, until they came back from the east. No edge, no falling off, just a full circle. Magellan's crew literally circled the planet. And they did it without a single satellite. Today we have photos from space, but back then, just shadows, stars, and bold ideas. So the next time you ask yourself something weird at 1 a.m., don't ignore it. You might stumble on the brilliance of ancient minds. Like, share, and subscribe for more midnight thoughts that make you smarter.